In the previous video we created a virtual machine which is currently running Ubuntu, and we're going to use this Ubuntu installation to help demonstrate the containers that we're going to be talking about in this video. So when people began to use virtual machines, they realised very quickly just how overkill they often were. If we take a very quick look at this installation for example, we can see that we have LibreOffice installed, we have Amazon installed, Thunderbird Mail. These are things that are never going to be used on a web server, and so are basically just taking up our resources. As people began to see just how overkill this process was, more and more people began to look at containers, which are virtual sandboxes, which allow web developers to take advantage of all of the benefits of virtual machines, but at a much lower cost. A typical container, for example, may only be a few hundred megabytes, compared to a virtual machine which may be several gigabytes. And you also need to factor in the CPU resources and memory resources that a virtual machine consumes, which compared to a container are very bloated. So containers are just what they sound like. They are containers of processors, and they're very, very lightweight, with only the very key software for that process included. And just to help demonstrate how lightweight they actually are, most of them won't include a text editor at all. So containers work well, but at the same time there was a push for more automation from the development communities. After all, people had become used to having disposable systems from virtual machines, and so projects sprung up to combine containers and automation. Probably the most popular of these projects is called Docker, which we will take a look at today. And we can of course use the docker.com website as a resource to help us with this process. So to actually install Docker, we need to first open up a terminal window, and we're first going to need to update our apt repository. So just to help us along with this, I'm going to actually sudo myself. So once that's done, we can go ahead and clear the screen. And we're going to need to ensure that we have wget installed, which we're going to use to actually download our packages. So we can test that by typing wget.version. And you can see that we are getting error messages. And so we can see that we have wget installed anyway. If you didn't have this, you would need to go ahead and download it. So now that we have it, wget installed, we can go ahead and use wget to actually download the newest Docker package. And so the command for this is very strange if you're not used to using wget, which is -qo, and then the path to the actual download, which is getdocker.com. And then we're also going to sh afterwards. So now that the download is installed, we can go ahead and, if we want to, we can add ourselves to the Docker group, but we're just going to use root for this demonstration. After all, we are using a throwaway virtual machine, so we're not too worried about the permissions of this virtual machine. So to test that Docker is installed correctly, you can simply type docker run hello world. And as you can see, in this instance I wasn't able to run Docker properly because the daemon wasn't running properly yet. So to start the daemon up, we simply need to type etc initd docker start. And as you can see, that's started correctly now. So let's run hello world again. As you can see, it's not able to find the version locally, and so it's gone ahead and downloaded something for us. And now we're presented with this message confirming that our installation is working correctly. So now that we know that we're able to run our commands properly, we're going to want to do something a little more complicated than just a simple hello world program. So if we go ahead over to docker.com, we can see we have Docker Hub here. Docker Hub is a list of all of the publicly available and publicly supported images, which are the underlying technology behind the containers. So we can, for example, search for Ubuntu, and this will show us a page of all of the current Ubuntu images. So we have Ubuntu Official here, as well as a whole host of other ones. So let's actually create an Ubuntu image. To do this, we're going to do the exact same command as we performed earlier, except we're going to use Ubuntu as the name instead of hello world. The run command is then going to find out that we don't have Ubuntu already locally, and so it's going to download all of those files. So now that's complete, but we aren't actually able to interact with that at the moment. So now if we type Docker images, we can see that we have our current images, which includes Ubuntu and the Hello World program that we initially used to test our Ubuntu installation. So we can go ahead and create a new container from our Ubuntu image. And to do this, we just need to type docker run. And then we're actually going to pass in two commands. We're going to pass in I and T. I tells Docker that we're going to want to interact with this container, and so the input from our keyboard and mouse should be passed across to it. The T tells it that we're going to want to see the terminal, so that we actually have some output and that we can see what we're importing. We're then going to need to specify the name of the image that we want to create our container from, as well as the commands that we're going to want to run. So to create an actual terminal, we're going to need to run the bin bash command. If we run this, you'll see that our actual machine name here has changed. And this is because we're actually now working on the container. If we open up a second terminal window and go ahead and sudo myself, and then run the docker ps command, we can see that we actually have this information here about the container that we've created. And so you can see that at the moment, the ID of the container is this digit string here. It's called Ubuntu from the image. The command we've run is bin bash, created about a minute ago. The status is that it's been up for about a minute. We don't have any open ports. And the automatically generated name is this thing. Now the great thing about containers is that we can do anything that we want with them. So if we want to look at the directory, we can see that we have all of these files. But because we're in this directory and this is a sandboxed environment, we can do anything that we want to. So we could, of course, delete everything. So you can see right now that all of the main files have already been deleted. We can't list any files at all. If we look in our main virtual machine, however, this hasn't affected anything. We're in our current directory still. It's only affected the contents of this container. This does, however, also mean that we can go ahead and create a new container from the Ubuntu image. Using the exact same command. And our new container is going to have all of the files that it should have, because of the fact that each of these individual containers is a completely isolated sandbox in its own right. So we can exit out of this container, and we can exit out of this other one as well. Now you may have noticed that we did use a command which we didn't actually talk about, which was the docker ps command. The docker ps command lists all of the currently running containers, but as you will have seen, we've actually just stopped both of our containers, and so there are no entries in this command displaying at the moment. The command does have an option, which is the A command, which lists all of the images that we've created in the past. This means that if we want to, we can go ahead and connect to one of the previously created images and start it up again. To do this, we type docker start and then the name or the ID of the container that we want to connect to. So if we copy and paste this, we can start this virtual machine back up again. So if we type docker ps again, we can see that this virtual machine starts up again. Now we obviously didn't connect to it again at that point because we didn't have the flags to connect to it, the I and T flags. But this does give us the opportunity to demonstrate another command, which is the docker kill command, which is, as you would expect, docker kill and then either the name or the ID of the image that we want to kill. So if we type docker ps again now, we can see that that image, or that container rather, has already been killed. Killing an image, however, only stops it from running. It doesn't actually delete it. So if we look at docker ps -a again, we can see that the image is still there. This first one. Just a very quick point about the start command as well, which I didn't mention at the time, which is that the start command is actually different to the run command. The run command will look for an image based on the commands that you've typed, and if it doesn't exist, it will download the image from the Docker Hub repository and then create a new container for you to use. The start command, however, only takes images which have already been downloaded and starts up new containers. The start command won't ever actually build a new image itself, only the container. So how do you go about actually creating an installation which is going to suit your exact purposes? Well, you could of course create a new image from any of these containers that we've created after we've gone ahead and customized them to our exact needs. But another alternative, and a more reliable alternative, is to create another image from what's called a Dockerfile. We're not going to talk about Dockerfiles in any detail in this video, but a Dockerfile is ultimately what is behind the creation of these images on Docker Hub. As you can see here, it talks about the Dockerfile, and if we click on any of these Dockerfile links, it will actually give us the Dockerfile which has been used to create the image. All a Dockerfile is a set of instructions which is run in sequence and produces an image based on the latest versions of the software included. So you can see here, for example, that we're using this particular tarball. If you were to take a look at some of the other options, for example, if you wanted to create a GitLab server, if we would look for the associated Docker files for these, we would see that these are actually going to download an actual operating system, as well as installing the software that we're going to need. And it's also going to set up all of the configuration. So you can see here, for example, the configuration files are being copied across into the relevant places. Creation of these Docker files can take a long time initially, but by doing so, you do end up with a repeatable solution, which means that every time you create a new image, you're going to include all of the same software, and you're going to be able to configure each image in the exact same manner, irrespective of any small version changes, which you can of course factor into the process. So before we end this video, there are just two more commands I want to mention to you, which are the deletion commands. We've obviously created this container here, but we're not going to want to keep this forever. We do want to eventually delete it. When we want to delete a container, we simply type docker rm and then the ID number of the image that we want to delete. If we type ps-a again, we can see that this image has now been deleted. And the command does change, so you don't need to perform the command each individual time that you want to run it. So we can copy and paste multiple ID numbers. And if we type docker ps-a, we can see that all of these previous containers have already been deleted. So what about the images? Well, as you can see at the moment, we have two images. We have the Ubuntu image and the Hello World image. The command is almost identical, but instead of just rm, we have rmi, which obviously stands for remove image. And again, we can use the name or the ID number again to delete each of these images. And we're getting an error message here because we haven't deleted all of the actual containers. So let's go ahead and do that first. And now if we try to delete both of these containers, both of these images rather, we can see that all of the files have been deleted. And the actual images are completely gone. As we've demonstrated on Docker Hub, we obviously don't just have the blank operating systems to start from. Many companies do provide actual official versions of their software through Docker Hub. So if you're considering setting up a service, checking Docker Hub first may be a good option for you, and it may save you some time in the long run, especially when it comes to configuration, because you can obviously rely on someone else to have done all of the installation for you. What do you think of this video? Has it been helpful? Have you learned something new? Let me know in the comments. Hit that subscribe button and check out some of these other videos.